really I was very shocked and very enjoyed, and it is a very great thing in her biodata. Dr. P. Shanmugavadi, Professor and Head, Department of Computer Science and Application, Gandhigram Rural University. Most of you aware of this ma'am. Most of you know about her. So still her coming into her academic field. In the research area, she guided 21 MP scholars and 9 she completed her PhD and 8 is guiding at present. Coming to the publication part, he published 2 books and 16 chapters in various books, and he published more than 100 journals, it seems, 133 national and international journals, edited volumes in various journals she published. And finally, if we coming into the funded research project, she got funding from various funding agencies such as UGC, DST, ICMR, etc. Totally, its financial outlay is 2.39 crore in various fundings. So really, it is a great achievement in her life. So we all got such an eminent person with us to share her knowledge, and we must get all the informations, and we will also grow through this FDP. This is our aim, and we all welcome everyone for this FDP, the 5th day FDP. Hope we will start. I hand over the session to Dr. Shanmugavadi. Ma'am, you can ask.
Shall we continue, ma'am?
You can carry on.
Hello, ma'am. Is the slide visible to everyone?
Yes, ma'am. Yes, ma'am.
Okay. So my sincere thanks to the organizers for having come out with this wonderful workshop, 5-day workshop. And I once again thank you all for giving me an opportunity to get connected with a galaxy of academicians as well as researchers. And it is always a pleasure to get in touch with the peer group and especially for the kind of knowledge dissemination or knowledge acquisition, whatever it is. So any kind of activity that we do in terms of attending or integrating oneself in a workshop is a part of knowledge acquisition. So in this line, I once again thank the organizers for this wonderful opportunity. And now I think I'm very happy to know that it was successfully going on for the past 4.5 days. And now you are at the fag end of this program. I think, is this the last session?
Yes, ma'am. This is the last session.
Okay, so I understand you will be on the verge of completing this course and then just pushing off. And however, let me try to be as brief as possible. And now this session will be on convolutional neural network. Now it is needless to mention that the entire world is reorienting and synchronizing itself in the light of artificial intelligence. Now, we just still wonder what made the entire world to get banged on artificial intelligence, whatever be the domain, may it be sciences, social sciences, management, business, then say astrology, astronomy, whatever it is. Now, this artificial intelligence has got a viable solution, optimal solution, and feasible solution. What made this artificial intelligence so special, so interesting, as well as and so worthwhile? The reasons are, number one, these artificial intelligent models or algorithms or techniques are able to give us the maximum accuracy which cannot be expected out of traditional computing technologies, number one. Then number two, we are living in data-driven era where we have voluminous of data being generated, and we are exposed to and good amount of data that we call as big data. And this big data has got a lot of hidden value, hidden potential, hidden pattern, which can be used for very many operations like data analysis, data analytics, and business intelligence, and all these things. What are we going to do with that? With that kind of data, we can go for prediction. We can predict something which is not available with us as of now. Or you can go for categorizing the data or categorizing certain problem that is given to you. So you can use it for classification, or else you can use it for clustering the data, or it can be for decision making, or it can be for regression. You try to extrapolate certain value and try to find out. So all these kind of operations are very, very important, or the need of the hour, irrespective of the disciplines, may it be science or social science or humanities or even languages or whatever it is. You just name a discipline, artificial intelligence finds its direct application. So, in the context, I felt it would be quite interesting to talk about this artificial neural network and then make you understand how the CNN work. And probably, or I think many of you might be having a kind of knowledge about CNN, or you may be like conversant with the concepts of convolutional neural network. Here, I just focus on how do you understand convolutional neural network, and if you understand the functionality, working principle of a convolutional neural network, and probably that will help us to just extend this concept for all possible problems that are to be solved. So this contains, I think, what is the time duration? For the teacher, it is not a problem, but the listener, it matters a lot. And madam, when is it? I mean, is it between 2 and 4? Hello.
Yes, ma'am.
Okay. I just want to confirm on it because I should not go on and on. So this we just have a kind of an overview about artificial intelligence. There may be certain overlapping with respect to slides because this is the last session, and I think definitely many of the faculty members might have touched upon the points that I'm going to discuss. If there is any repetition, kindly excuse me. So then deep learning and introduction, then challenges in neural network, convolution neural network, then I'll just finish with popular CNN techniques. So this is the picture of the father of artificial intelligence. All of you must be knowing about this personality. He is John McCarthy. He is called as father of artificial intelligence because he is the one who coined the terminology artificial intelligence when he decided to submit a proposal for one such winter workshop that he wanted to organize to explore the viability of formulating the theoretical basis for artificial intelligence. After the invention of Turing machine by Alan Turing, he wanted to expedite how far it is possible and what are the theoretical support that we need for the idea of artificial intelligence, that is the science of making the machines to behave like human beings. So he decided to just explore how far we can just achieve this artificial intelligence, how far we can implement, how far we can realize. And for this purpose, he called upon scientists from different diversified disciplines, right from sciences, from sociology, from psychology, from number theory, and from theoretical computation, and biology, and then genetics and whatnot. So he just wanted to organize a very broad and very exhaustive workshop on artificial intelligence. For that purpose, he coined this terminology, artificial intelligence. Even John McCarthy wouldn't have dreamt that this artificial intelligence will be banging this entire world in the way that it is happening now. So now he is a very popular scientist in terms of computer science and mathematics because he has contributed to the development of Lisp programming, ALGOL, that is Lisp programming, Lisp, ALGOL, algorithmic languages, and he also has contributed to conceive the idea and implementation of time sharing in operating system. So he was very influential in the early development of artificial intelligence. So now, what is artificial intelligence all about? Because artificial intelligence is nothing but
Ma'am, ma'am, hope it's some network issue, I think so. Ma'am,
Ma'am has some network issues.
yes, I think so,
I
ma'am.
joined.
Ma'am?
Giant, ma'am.
Hello, I'm extremely
Yes,
sorry.
ma'am. No
All
problem, no problem.
networks and landline, Wi-Fi, nothing works at times. I'm
Anyway,
okay.
no problem, ma'am. You can start.
Thank you. Once again, it's taking time.
It's okay, ma'am.
Okay, so let me continue, and please let me know if it gets cut because I may not be knowing.
Okay, ma'am. Yes.
Thank you. Okay. So we just talked with what is meant by artificial intelligence. It is a simulation of intelligent behavior in computers. So we just understand artificial intelligence as simply the capability of a machine to just imitate or to simulate or to exhibit the natural intelligence as it is exhibited by the human. So it is defined this way. Artificial intelligence refers to systems designed by human that a given complex goal act in a physical or digital world by perceiving the environment. Suppose if it is going to be an artificial intelligence model that is working in a machine, then it perceives digital environment. If you design a robot that's going to use the artificial intelligence of say computer vision or decision making, it's going to get executed in the physical environment, interpreting the collected structured and unstructured data, reasoning on the knowledge derived from this data, and deciding the best action to take according to the predefined parameters. And for each kind of problem that you handle, it has got a specified goal. That is, it has got a goal to be achieved. For instance, if it is for say medical image processing, it is identification of disease or identification of a tumor or concluding whether the result is positive or negative. And suppose if it is a robot that is going to walk, it has to find its way, it has to track its pathway, and then it has to identify the objects in front of it and decide whether it is an obstacle or whether it is the object that it has to take, and many such things. So the goals are going to be totally different from each problem, and however, depending upon the goal, we set the parameters. Okay, what is the necessity for us to turn our attention completely towards artificial intelligence? One, it is the one of the fast growing and cutting edge technologies. Then it redefines the art of computing for problem solving. At this point of time, I just want to draw your attention wherein traditional computing was very comfortable with us, and we were comfortable with traditional computing, and we were very conversant with using C, C++, Java, and different other software tools. But now, what is so special about this artificial intelligence? Point number one, as it is told, it is a fast growing and cutting edge technology. The number two, this application of artificial intelligence is going to open up the new arena of computing. And excuse me. So redefine the art of computing for problem solving. Now, once you start working with artificial intelligence models, you will be able to distinguish the clear-cut distinction between traditional computing models and artificial intelligence models. I just leave it to you open until we complete the session. So it has brought in a paradigm shift in the process of computing. Now, as you look into the art of problem solving, procedure of problem solving, it is radically different from that of the style that we use in traditional computing. It offers a spectrum of computing models for problem solving. because we will be having good collections like machine learning models, then artificial neural network, then CNN, then transfer learning models. It has got good array, good spectrum of computing models available for problem solving. And then it is capable of handling the so-called big data. And it never uses, it never requires, it never demands human intervention, because once the model is developed and deployed, it becomes 100% totally automatic. So AI is ideally suitable for interdisciplinary problems. Underline this. That is the reason why we talk at length about this artificial intelligence. So these are the kind of representation that we can show with respect to artificial intelligence. And the superset is artificial intelligence, whereas the machine learning comes as a kind of subset of artificial intelligence. And this neural network is again a subset of artificial intelligence and a new discipline of this artificial intelligence. So this neural network this paves for the development of deep learning. Now, whatever be the limitation that you have with respect to this neural network, and that has been alleviated by the support of deep learning technique. So from this deep learning, you can understand. Now, there is a difference between reading a newspaper and by hearting a sloka or by hearting a text. So now, if you just have to read, you don't have to put your mind and heart and then just read it and forget it. But in the case of deep learning, when you want to by heart something and reproduce it, you have to put your mind and heart together and follow what it is and see the sequences, and you must be able to recite it in the similar way. Now, as you look into the severity, kind of seriousness that should be shown by the models in solving the problem, there is a clear-cut distinction between a machine learning model, neural network, and deep learning, because the learning process for the machine will be much higher. Okay. Then we talk about this deep learning, and you can say this deep learning as an outgrowth of machine learning, and it's proven to be exceptionally good in learning pattern. Now, once again, I wish to draw your attention. Now, how do we get knowledge? How do you get experience? And how do we acquire skills? And how do we acquire expertise? It all happens all because we either learn or get trained. So this learning and training are the two buzzwords, two keywords with the support of which we try to augment our knowledge domain. In the similar way, when we want the machines to behave like a human being in problem solving, may it be prediction, may it be decision making, may it be classification, may it be clustering, may it be regression analysis, whatever be the kind of problem. Now, make the intelligence of human. Right? And how are we going to make this simulated human intelligence available for the machine? That happens with the support of the collection of algorithms we have got. So it uses the learning algorithms to extract the deeper patterns out of the data. Then it is capable of handling voluminous data for better learning. That is one of the added advantages of deep learning. So it mimics the functionality of human brain in processing data for use and in decision making. It can also learn from data that is both unstructured as well as unlabeled. I think I don't have to speak much about this. You all must be knowing what is supervised learning, what is unsupervised learning, what is reinforcement learning, and how best we can train all these models. Are we going to use labeled data, that is data set that has both input and output, or are we going to meddle with unlabeled data that has only the input parameter values, not the output? Or else, are we going to use the unstructured data, or unlabeled data means the data set without the output? Unstructured data set means now for each kind of data item, the structure is not going to be the same. It can be just a numerical value for some other parameter. It can be an audio. For another parameter, it can be a video, or it can be a text, or it can be a kind of icon, or it can be emoticons, and many such things. So manually designed features are proven to be overspecified, often incomplete, and take a long time to design and validate. Now, suppose when you want to identify a person's face, right? Now we just look into the pattern of eyebrows, eyes, nose, mouth, and then we just form a pattern about a person, and that image will be stored in our brain. And when we get to see the person all over again, then the brain extracts that pattern and then matches and tries to come out with identification of a person if possible. So in the similar way, when you want to develop an artificial intelligence model for face recognition, then you just have to train the model with good collection of images for which you want to develop an um, artificial intelligence driven face recognition system. So in such cases, we have to make this extraction process manually available, and then manually available, and then that should be given to CNN, convolutional neural network. This process is called, as you all must be knowing, feature extraction. Now, what are the features to be extracted? Suppose if I want to develop a face recognition system, is it just sufficient if I just extract only the eyes and nose? Don't I need the mouth? Don't I need the skeletal shape of the face? If that is decided based upon the problem domain, right, we call that as feature engineering, right? This feature engineering, feature extraction are very important domains of research when you do research in artificial intelligence. In addition to that, now suppose if you have, for instance, a collection of data which are erroneous, which are not intact, then you have to go for pre-processing either the data or the image. That you call as data imputation, or that you call as image pre-processing. If it is data, then you call it as data imputation, data cleaning or data pre-processing. And if that deals with image, you call it as image pre-processing. That involves a noise reduction, then contrast enhancement, brightness adjustment, and things like that. So here from this slide, the understanding is when we extract such kind of features for face recognition, eyes, nose, mouth, etc., then it becomes little harder for us to understand like what are the features to be extracted. But however, if you just make it as ideally mechanical, like automatic, then the model can decide what are the features to be done, and that happens with the support of deep learning. So suppose when you talk about the features, then you are given an image, then you have to handcraft the features, we extract it, and that's going to be sent to a simple trainable classifier, then you produce the output. So the limitations are, it's very hard to handcraft the features manually, whereas as we move to deep learning models, everything becomes automatic. In addition to that, we just talk only about these features, but here we talk about low-level feature, mid-level feature, high-level feature. So all these different levels of features and the details are going to be used for a model, so it becomes highly robust. So popular implementation, you can use it for personal assistant recommendation system, then identification, facial identification, personal identification, robo assistant, then chatbots, then data visualization, then sentiment analysis, and then smart payments, and many more. So these are the steps involved in any kind of steps that you have for solving a given problem using artificial intelligence. So collect the relevant data, clean and prepare, and keep the data intact. Then you select a model, select an artificial intelligence algorithm, and then select the model. Then you train the model and see what is the performance with respect to the metrics and measures. And once you are convinced, move on to the test data, where you do the same process of either prediction or classification or clustering by using a subset of data of the entire data set. So once the training model and testing models are obtained successfully, then we can move on to improving the model, which is order of the day for any system that you use. It is subjected to augmentation of features, are subjected to revision, upgradation, or enhancement. So this is about the artificial neural network that mimics the neural network system that you have in your human body. So ANN, or neural network, or machine learning computational algorithm modeled after the human brain. So it is a technology that based on the structure of the neurons inside the human brain, which contains a number of artificial neurons. So it will try to create a function. Now this, you please understand, when you take any model, may it be a linear regression or multilinear regression, or it can be classification, identification, whatever be the problem that you want to solve using artificial intelligence, it is going to develop a mapping function what is the mapping function? It tries to find out the relationship between the input data and the output data. For instance, if I say x is equal to 1 and y is equal to 1, if I say x is equal to 2 and y is equal to 4, if I say x is equal to 3 and y is equal to 9, then easily any one of us can formulate a mapping function between input and output as y is equal to x square or y is equal to x into x. So this is a kind of mathematical association that we try to develop from the input and the output. So just look into it, and this is the input layer, and here you have got this kind of neurons, and then this is one layer, this is another layer, and because we deal with deep neural network, we have got all these things. Then whatever to be done here, that's also done, right? So this is the input. Red color ones are input, and then sky blue color, this is the output. Intermediate ones are intermediate values. So let's quickly go through this. Suppose if I have this as the neural network pattern, right, that has got all these kind of W1, W2, W3, X1, X2, X3 are the respective, X1 to Xn are the input parameters, W1 to Wn are the weights that are assigned to all these kind of inputs. So now this any trainable model, say support vector machine or naive-Bayes classifier or any decision making process that involves computation of this formula, you can see here. See, we have to multiply x1 with w1, x2 with w2, x3, xn with wn. We just find the summation of all these things. In addition to that, we just introduced one component you can see on your right side called bias, right? So we just calculate this, and that information is going to be passed on to the next layer, and so on, and then you complete your process of computation. So x, all the x are the inputs, w are the weights, and b stands for bias, right, in this computation. And what else? Y is the output, then f is the activation function. So I hope you understand what is meant by an activation function. Okay, what are the capabilities? Neural network can be used to solve problems related to, it can handle any kind of data. It can be tabular data, it can be image data, it can be text data. It is capable of learning any non-linear function, hence it is known as universal function approximator. As it can handle any kind of problem, it's being called as universal function approximator. It is capable of getting some weightage for each and every input, then the computation goes on as you have for this activation function, and then you are able to correlate the values that you have computed with reference to computing the output, based on which you can go for prediction or classification. So we have got the input. For each input there is some weightage, and based on the weightage we decide about this neural function. And suppose if that is say let's take this for instance. So 1 the respective weight, 1 into respective weight, 2 into the respective weight, 3 I think 2.1 into the respective weight, and 1 point into the respective weight. So what happens once you supply all this data, then it formulates an activation function. So then that activation function becomes the predominant common model. So when I give data which is not part of this, when I give some other data, then also we will be able to manage. So artificial intelligence, machine learning, ANN, then DNN. So these are all the kind of deep learning neural networks model you have got, and you can have as many hidden layers as possible. As you increase the number of hidden layers, then you will have more number of computations, then you will have better scope for improving it. So CNN are all the range in deep learning community right now. So any kind of problem that you want to solve, right? And if that has got scope for solving using artificial intelligence, then it is just amazing. So CNN are all the rage in the deep learning deep learning community. Just right now, this is what we use. So these CNN models are being used across different applications and domains, and they are especially prevalent in image and video processing applications. So you can just quote unquote, this finds a lot of application with respect to image and video processing. So this is all about CNN. CNN you have, then you can identify the emotions, whether that particular image represents happiness or sad. So you can see here how it identifies, like this is the peak, right? So that has been taken, and then you try to improve it. To make, why do we have to improve the quality of the images that we have got in the hand or videos? Because when the machine is going to handle these kind of data, then you have to refine the input data, as well as you have to facilitate the process of understanding the data and producing the accurate results. Okay. So here you can see that this refers to the mapping function that is formulated. Okay, so the CNN is a pointwise multiplication of two functions to produce the third function. Then this primary purpose of CNN is to extract the features from the input. That is the main purpose. And once the features are extracted, then you can give it to this part. See, this is the input. Then we have taken certain parts of this bird, and that involves cooling, and don't worry about all those things. It's all very simple. And once you do this extraction, then at this point you put a barrier and say that this is one part. On the left side is one part and the right side is the other part, right? So whatever that you extract is going to be managed with the CNN, fully connected layers which are given here, and this is the final output. We just want to identify whether the given image belongs to a bird or sunset, or dog or cat. Please excuse me 1 minute. Hello, sir. Yeah, I think calling from NIR, right? Okay, we are in the process of getting approval from the Vice Chancellor, and we have given the letter for the genesis of the institution. Once it is done, we are at it. Okay. So now, whatever be the information, for instance, just imagine, extracting features from our face, eyes, nose, mouth, lips, then the earlobes, all those are being called as feature. So whatever that we extract out of the given image by using the operation called convolution operation, it's called as convolved feature or activation map or a feature map, right? So this involves like a lot of operations, and interestingly, to work with artificial intelligence, we should have the basic understanding about basic mathematics, then statistics, probability, and a little bit about the information theory. But interestingly, and to really work with the code, right, you need very minimum knowledge. Then why do you have to learn the theoretical aspects of artificial intelligence? As in when you have thorough understanding about these kind of models, and if those models are present, then you can just make use of the model to get the appropriate result, whatever that you want. And you can see here, right, cat, dog, and this convolution operation is going on, and ultimately you get the output. If this cat is given, then it is taken as okay, and if this is other way around, then you get the corresponding value. So don't worry about all these things. So this is all about the CNN layer. CNN is composed of stacking several building blocks. So take a note of all these things. You have to perform convolution operation. So you have convolution layer. Then this cooling layer is yet another layer which has got a specific purpose. So please remember. And if I have an image, for instance, a medical image. So whenever we apply this convolution operation, then that convolution operation shall try to extract certain features from the given image, and that feature that you extract, right, is going to be processed further. So when you extract the features, naturally every one of us can understand the size of the convolved feature is going to be much lesser than in size than the original one. See, when I take my photograph and I just extract my eyes, nose, mouth, lips, etc., I just keep it in another file, then naturally the size is going to be lesser. So we have to keep in our mind, after performing the convolution operation, the size of the given input image gets reduced, number one. So when it is reduced, we call that as dimensionality reduction. That is, the dimension of the input image is getting reduced. So we call that as dimensionality reduction. And after that, suppose when you do this kind of operation, I told you the size may reduce. In order to retain the original size, we just add zeros on all the four sides of the image, so that when you get the processed image, the size will be the same. It will be just, if it is 4 cross 4, then it remains as 4 cross 4. This is one aspect. And after that, once you extract the features, you must have seen here, then it is given to the fully connected layer. Once the features are extracted, then you have to deal with this. So these are all the operations that we perform, right? And when you do this operation, there are two flavors with which we can do. One is striding, one is padding. And what is striding? The pattern in which we move the convolution net window across the image. I think all of us must have done this like a child's play. Suppose when I have this image, if I have 3 cross 3 convolution operation, for the first time, the first 3 cross 3, and then the next time, second, third, fourth, and then third time, third, fourth, fifth, and so on. So don't worry much about it. I'll explain to you here. So now let us see how this is going to be done. Now let's imagine you're going to develop a model, right? You have an image from which you're going to extract the features. Now this is called as convolution window, or you can call as feature detector. Why it is called as feature detector? Because it is going to extract the features and then remove it. And now you can see I have taken 3 cross 3, that is multiplied with 0, 0, 1, 1, 0, 0, 0, 1, 1. So you can see here, now this data is multiplied with this data, 0 with 0, the 0 with 0, then this 0 with this 1. Okay, so correspondingly you are going to do all this multiplication, you get the result as 0. Likewise, so you can see here, what is the size of this input? 1, 2, 3, 4, 5, 6, 7 cross 7. Now it is 1, 2, 3, 4, 5. So 5 cross 5, the size has got reduced. When I don't want this to get reduced to 5 cross 5, but I still want to keep it as 7 cross 7, I have to go for padding, right? So don't worry much about this kind of operation. This is because for computer science, it is 1 point operation. First position multiplied with first position, second position with second, and third position with third. So what you do is, for one, just see here, for one feature detector, what you get is, you get one filtered value. If I'm going to use multiple filters, such filters, I just get as many features as possible. So from the image, from the given image, we try to apply this convolution operation and get the extracts as much as we can. So then this is the ReLU is the one. And when you do the intermediate computations, that happens in the CNN, and the intermediate value that you get may not be in the form that we can understand. That may vary with unbounded values. So in order to make the unbounded values into bounded value, like suppose if I have values like with minus 1 to plus 1, I can make it a 0 to 1. So when I try to reorient the boundaries of the given image, or when you just want to, sometimes they want to reduce it, sometimes they want to retain it. So you get all this kind of things. So when you have such kind of unbounded value, we apply this. This ReLU, and we call that as activation function. சொல்லுங்க ஆன்லைன்ல இருக்கேன் சைன் பண்ணா கொடுத்துறோம் டிபார்ட்மென்ட்ல இருக்கேன் இந்த இதுல ஆன்லைன் மீட்டிங்ல இருக்கு நீங்க பாருங்க நீங்க கிளியர் பண்ணுங்க எனக்கு So when you have this kind of activation function, this activation function will convert unbounded data into bounded data. So the model will be able to make conclusions in the best possible way. So that's the purpose of this ReLU. You can see here, and the values will get truncated, and accordingly you get bounded data by using this ReLU. Okay. So you can apply after you finish with ReLU. We apply the next step called pooling. Pooling layer replaces the output of the network at certain locations by deriving a summary statistics of the nearby. If I take this 2 cross 2 data, the model may take maximum value where the maximum is 20, or it can go for minimum value which is 8, or it can find the summation of this as 20, 40, 52, or it can be average, all 52 divided by 4 as 13. So whatever that you want to do, you can do, but however, you have to have a justification about which one is correct and which one is not. Okay. So this is max pooling. I have already shown you what is convolution. That is, it is the process of going for one-to-one multiplication. We take each position and then multiply. This is a convolution operation. Then the next one is, after convolution, you go for redo. Then you go for this pooling. This is the example for max pooling. So max pooling, you get the maximum value. Minimum pooling, you get the minimum value. Okay. So this is an example for max pooling. So with max pooling, you can understand input is taken, then convolution operation is performed. After pooling is done, you get this pooling layer. Now you have to go in for flattening. Please try to understand. Now we have done all this max pooling, everything. So you'll be getting some max pooled value. Now let us imagine you have got this as the pooled feature map. This is the final feature map that I have taken. Now it is going to be 1 1 0 4 2 1 0 2 1. This is the kind of linearized data that you get. So once you get this kind of linearized data, then what happens now? Each one will be interpreted in the best possible way. This is what we call as flattening. You take the results of the pooling layer and try to flatten it. So this is going to formulate the input layer of the then like whatever like you have extracted. This can be like eyes, nose, or any feature. So please try to remember whatever you have extracted after this pooling, and once it is flattened, it is going to be fed into. I'll show you. This one. Yes. So now this is what we have seen. You take the image, we apply convolution operation, then you apply ReLU, then you do max pooling. You get some two-dimensional data that has been vectorized, that has been flattened, and once it is flattened, then you have to go for fully connected layer operations. So the whatever be the features we have extracted, that is getting flattened. Then we go in for one-to-one connection. So each and every data is connected to the output in the output. I mean in the text layer. This is what we call as fully connected layer connect. So we have got this. Now after flattening, you get this kind of features. Then these features, flattened features, are going to be used into this neural network. So fully connected layer and dense layer. Now these extracted features are going to get used in the fully connected layer. Now you can see whatever that you have extracted in terms of these bubbles, right? Each one refers to one input parameter. Please remember, each one hello? Am I audible to you, please? Okay, thank you. Maybe proceed. Hello.
Ma'am?
Can you hear me, please?
Yes, ma'am. Is audible? You can proceed, ma'am.
Okay, right. No, I understand. I have only been. Are the slides? Can you see my slides?
No, ma'am. Now it's not able to see.
Okay, right. One second. There is a small delay. Can you? I think I'm not able to present my PowerPoint. Should it be enabled? Okay, now I have got it. Okay, so now I have got this input parameters. We were talking about fully connected layer, dense layer. I have shown the image also. Now these are the input parameters we have extracted from the image. So now you apply it to the neural network, and then you come out with some conclusions. Now in your system, you must have given enough data to make the machine understand what will be the feature of a dog and what will be the feature of a cat, of a bird. So for each kind of category, it will be able to come out with a percentage. Like say, suppose if the model is going to identify dog as 95% and cat as 5%, then the accuracy is higher for dog. So that image will be concluded as dog. So you take the input, we apply the convolution operation, we perform this ReLU is part of convolution. Then you apply this convolution operation, and then you extract the input data, and then you try to give it to the network, and this is how it works. So whatever you get in the output, this is what we have seen. So the whole CNN, we have got the fully connected feedback. This is what we were discussing in the previous slide. You take an image, you do the convolution operation, then apply max pooling. Then again go for convolution operation, then perform pooling, then flatten it, and then give it to your fully connected CNN. So these are all the famous models that LeNet, AlexNet, ZFNet, all the years of introduction are being given. But now we have got few more collection of CNN, PGGNet. You can experiment with GoogleNet, RestNet, Inception, UNet, MobileNet. Now we have got SegNet, and many more. And even the new versions of this net can also be found. So before jumping, and you have to, how do you plan for your implementation of CNN? Before jumping in, you have to understand the original data and the original label. That is, if you're going to work with images, you should understand what are the types of images I have got. So understanding the original data and original label, then implement pre-process functions like normalization, one-hot encoding, data split, in training, validation, testing. All these things matter a lot. So you have to have the basic understanding about what are the kind of normalization I can apply in order to make my data ready for execution, and then what are the kind of pre-processing techniques can I apply? Do I have to go for a noise elimination in the data, or should I go for estimation of the missing value, or should I ignore the missing values? All this kind of data should be familiar with you, number one. And then you go for building the network, CNN model with the cost function, and then optimizer. So we try to work with respect to this optimizer. Optimizer is at another domain, and once you are thorough with these kinds of models, then you can extend your knowledge on optimizers. Because if you want to write high quality research, and you have to have this optimizers along, and without optimizers, like you cannot. Come out with a full-fledged enriched research paper in artificial intelligence. And to train the neural network, there is another component when you work with artificial intelligence models called hyperparameters. So for every model, there are certain parameters which are exclusively related to that model. If I take linear regression, it has got a set of hyperparameters which are highly exclusive. If I talk about decision tree, it has got a set of hyperparameters. If I talk about CNN, it has yet another set of hyperparameters. So we try to give ideal value for these parameters and slightly adjust the value. That's known as hyperparameters. So then training the model, it just happens with respect to how do you make an algorithm to understand the patterns hidden in the data so that it will be able to understand the pattern as the human brain can do. Then you test it. So you have to, obtain as many metrics as possible to validate, to ascertain the training as well as test model process. And if you are comfortable, if you are convinced about the accuracy of the model, then you can proceed. And if you still feel that there is a further scope for improving the prediction accuracy or computation accuracy or classification accuracy of the model, you are welcome, and you can continue with hyperparameter tuning as well as applying optimizers. So this is a Cipher 10 data set which contains 10 different types of objects, like right from aeroplane to truck. So if we give this Cipher data set to a model, the model will understand what do you mean by a dog, what do you mean by a frog, what do you mean by a heart. So it just makes sense. So you need to have the input. It can be of any size. Then we have to understand what is meant by convolution layer. So this is how we have the architecture: input, convolution layer, ReLU, pooling, and then fully connected layer. So what is the purpose of this input? That will hold the raw pixel values of the image. That is an image whose width is 32 into 30, 32. And this 3 for tricolor, red, green, and then blue. And then convolution layer will compute the output of neurons that are connected to the local region in the input, each computing a dot product between their weights. That is how do you perform this convolution. I have shown you an example, point-point multiplication. Then ReLU layer, this is used for channelizing the data, right? And it can be, if you don't use ReLU, it is very hard for the model to conclude with respect to the outcomes it gets. So it does the process of fine tuning. ReLU does the process of fine tuning in order to fit the intermediate computed value within a fixed boundary, maybe from 0 to 1 or -1 to +1 and 0 to -1, as you like. Then the next one is pooling layer, where you find maximum value, min value, or summation or average, and one such things. Then the last one is fully connected. I also had shown you what is meant by fully connected. For between two layers, each node will get connected to all other nodes in the next layer. This is what you call as fully connected. So these are all the illustrations I have got for just working with pre-processing, and then you can, if I can share this with your organizers, they can just share it with you further. So importing the necessary libraries and data set, all these things I have given, and we can see here. I have imported the Cipher 10 data set. Then you have to take care of what is meant by dense layer and how many dropouts will be given, and how do you flatten. That is from with respect to dense, dropout, flatten, convolution, 2D, two-dimensional. From Keras, layer dot convolution import, max pooling. Here we use max pooling. So we have to download all these components, right? We have to import them. And then import matplotlib when you want to visualize it, when you want to show the results in the graphical form, we need all these things. So from here you can see, now we just split the data into two as X train, Y train, X plus X test as well as Y test. So that will be your data set. So when you talk about any kind of AI model, this training and testing phase plays a vital role in making the model to do its operation with the maximum accuracy possible. So in this line, we have to understand how do you classify them into say training data set, testing data set. If I have 100 records, probably I can just one second. Hello ma. இந்த இன்னொரு பத்து வருஷத்துல முடிச்சிடுறேம்மா. அவங்க வந்து கூப்பிட்டாங்க, நான் சொல்லிட்டேன். அவங்க கூப்பிட்டாங்களா? சரி. அவங்க சொன்னாங்க நான் இங்கிலீஷ் பண்ண சொல்லியிருக்கேன், நான் வந்துடுறோம்னு சொல்லியிருக்கேன். ஒரு 10-15 மினிட்ஸ்ல முடிச்சு நம்ம 3:45 கிளம்பலாம். So here we have this training and data, and I told you that if you have 100 records in a data set, and probably you can split it into 60-40 or 70-30 or 60 for training and 40% of data for testing, or 70% for training and 30% for testing, and there is no hard and fast rule, or there is no thumb rule that this is the percentage of division that you have to do. Everything in terms of artificial intelligence is concerned, everything should be ascertained, should be confirmed by trial and error, and you should work with the model in all possible values and try to see for what set of data it gives the best result. So it can training set, then validation data set. Just try to learn what is the scope of this training process, what is the scope of this validation process, what is the scope of this testing process. You will understand, and with what sense are we doing all these things. So if you take the entire data set, it can be training, then validation, and then testing. And that is called as holdout. Like when you do the process of data splitting, and you can have different combinations of holdout that will help you to have different combinations of data through which the model is getting trained, right? Suppose if I'm going to evaluate what is the performance of my teaching with respect to the entire students who attended my class, and if I'm just going to do the evaluation with respect to only the first 2 rows, it may be very excellent. If I do it with the last 2 rows, it may be very bad or worse. So only when I have mixed combination of first row, middle row, last row, when I do the process of evaluation, then I'll be able to get 100% 360-degree picture about my process. So this is what we mean by this selecting data for training, validation, and testing. Okay, so these are all the code for doing this. This is, I told about one-hot encoding, which works with replacing the unknown values or making them more meaningful and relevant. And this is building the network. You can see here, this is convolutional 2D, right? So when you start working, you'll be able to understand. So for my model, it just works out to be 40, also 74, right? So you can get the accuracy printed by means of this accuracy. You can just give it by the accuracy score. So now it's only 74%. There is still hope for us to improve it better in a better way. So we can just improve on hyperparameter tuning. Then we can go for changing the learning rate, or we can go for going for different combinations of training, validation, testing. We can just try with all possible combinations. So then here we represent the accuracy of the model for training and testing. So you can there is another component called epoch. How many number of times you're going to work with this. So for various epochs, we have plotted the graph, and we can understand. Accuracy and error are complementing. Reciprocating each other. Like if the accuracy is high, error is low. If the error is high, accuracy is low. So they are reciprocal to each other. So the test model, and here also we just validate how many dogs are being categorized correctly, automobile. Then this is being taken as a dog, and for each there is a specific set of features which are identified in the model. The support of which Google CEO says, in the long run, we are evolving a computing from a mobile first to an AI first world. So it is totally changing, and the mobile technology and cloud computing, artificial intelligence models, then big data analytics, then big data platforms, all are giving enough and more opportunities to widen our attention, to widen our solution domain, so that it becomes more and more complementary. So I have chosen all the materials from the internet, and this is what I wanted to make a mention about this artificial neural network. And I will be happy if you could. Can you see my slide? Hello.
Yes, ma'am.
Okay, I'll be happy if there are any queries with you regarding the CNN or anything related to this. And once again, I thank the authorities of Sri Ramakrishna Institution and the August organizers for having given me an opportunity to get connected to every one of you. This is only sharing of knowledge, and you all must be doing even better understanding about this. But in the given chance, I just tried my best to make you understand what is meant by CNN and what is the implications of CNN, how we can apply CNN for very many applications across the discipline within your discipline. And I'll be happy to take few questions if any. I once again apologize for the inconveniences caused because there was some network issue. I'm sorry for the delay that is incurred.
Thank you, ma'am. Thank you so much, ma'am.
Okay. And
Yeah.
here there is one CAS interviews going on. So
Oh, second.
I was invited in the middle, but even then I cannot.
Okay.
So, but still I have it. I still have 10 more minutes time. I have to start.
Yeah, thank you. Thanks a lot, ma'am. Thank you so much, ma'am.
Questions
But
to be deliberated. Please feel participants, because there is no one is will be an expert in the any given domain, because learning is a continuous process. Knowledge augmentation should happen in continuum.
yes, ma'am. Sure, ma'am. So this is the time to wind up with wholehearted thanks to everyone. My hearty thanks to the speaker of this day, Dr. Shanmugha Vadivu. I think everyone enjoyed and we got lot of information about CNN. And so still, if the connection and everything is okay, ma'am, still is planned to give so many things. I think so, ma'am. Is it correct, ma'am? But anyway, we got lot of informations, ma'am. Thanks a lot, ma'am.
The entire syllabus. Probably I would have shown you another example. Like
Okay, ma'am.
Share that PPT also with you. You can just share it with.
Yes, sure, ma'am. Thank you, ma'am. Thank you, ma'am.
It will be a kind of self-learning tutorial, like an example is given, and you can go through that. I'll share it tonight, and you can share it with your.
Yes, ma'am. Sure, ma'am. Sure, ma'am. I think participant you also got, ma'am also shared, we will also share it in the group. You can also use it. You learn everything. So no problem. So this is the time to thank everyone. So here, first I'm supposed to thank the HODs of both the department, Dr. Shumati and G. Marie Priscilla, HOD Department of Computer Science. Both of them gave opportunity for us to organize this such an wonderful FDP. And our hearty thanks to our principal, always motivating us and behind us, and he will give you all the suggestions and completing this FDP. And this is the time to thank all the participants. Actually, without you, there is not succeed. So everyone, you got lot of information. I think so, because as we are in the computer science field, we are supposed to learn not every month or every year, day by day. We are supposed to update ourselves. Otherwise, it is very difficult. We all know that. That's why we don't have time to to. When I know everyone having a busy schedule. Within the schedule, we don't have. Sometimes we feel we wish to learn something or we wish to read something. Sometimes we won't get the time. But these kind of FDPs will help us to update ourselves in the latest field of technology. In the first day, security issues in cloud, which was given by the Dr. Z. Zairaj, really it was a wonderful thing. He is also a busy person. He gave an excellent what are the items on. He did his projects and everything he shown us. It was really quite interesting. And the second day, Dr. S. Ramkumar from Christ University gave all his models and about the neural networks, and he gave all the projects what he did and how to do it, and he gives lot of ideas about that. The third day of the FDP, NLP and cloud computing, which was presented by Dr. Ajit Singh. Really, it is also very good. He gave all the basic things what we should know. And in the fourth day, really, it is everyone must say it's a really great thing, because that day we got lot of information about the new field reinforcement learning, so which was quite interesting and very good. And in the last, the final day, the conventional neural network by Dr. Shanmuga Vadibu, I think this also we got lot of information. So this is my time to thank from my bottom of the heart all the 5 speakers. They all spend their value time, and they just share their knowledge without any interruption or something. They just accept, and they gave an excellent talk, especially 2 hours. So solid 2 hours they just spend with us. Really, it will be our hearty thanks to everyone. And once again, my hearty thanks to the participants and all the support staff, coordinators and the conveners of this FTP. Really, my hearty thanks to everyone. Finally, I think you got the feedback of the 5th day. You can fill the feedback. And don't worry, we will share the quiz the end of the session. You all attend the quiz, so certificate you will get you within a week. So no need to worry about that. That quiz link will also be shared in the WhatsApp group. Okay, thank you so much. Thank you, participant. Thank you, ma'am. Thank you so much, ma'am. In between the busy schedule, you gave your valuable time. You shared your time with us. Thanks a lot, ma'am. Thank you so much.
No, it's my
Everyone.
pleasure too. It's my pleasure too, and it's very interesting to see the number which increased after I started the session. So usually during the last session and when the session is about to get over, the number will be just coming down. It will be just falling down. And like I really appreciate all the participants who can
Yes, yes,
get
ma'am.
on with the session, and I think it counts to 8 to 9. And it is very heartening, very much heartening that you're all very sincere. And my small piece of, it's not advice, a piece of information. And whenever you do a FDP, you will just quit. I mean, you will complete the FDP with lots of dreams, lot of plans of action, and lot of aspiration and interest. And please don't let that aspiration to just get faded away. And because like you will have that interest for about 2-3 days to come, and then you will just forget about it. And please don't do that. Please take all the ideas you have and just implement somewhere and make it as a paper. That is the purpose of attending this FDP. So all the best to you. And,
Yes.
best wishes to you. And,
Thank you, ma'am.
please get in touch with me. I have given my email ID in the PPT.
Yeah, you just share in the chat box, no, ma'am?
Yes,
Yeah.
I'll share with the PPT, and definitely I'll be able to help you if you have any specific queries to be clarified. My number is also given. Please feel free to contact me, and I will be able to help you if I can.
Yes, ma'am.
Right? Okay. Right.
Thank you, ma'am. Thank you so much. Thanks, everyone.
Everyone, yes.
Possibly, everyone, you can switch on your video. Let us take a photograph today.
Yes, I have done.
Yeah, please. If you open your video, we'll take a photograph of today's session, the final day. Prabhu Shankar sir, so many people are there still. Please, all of you, unmute your video. Aarti, take a photo, Aarti. Aarti or Karti, please take a photograph of this. Finish, Rati? Yes? Thank you, ma'am. Thank you, sir.
Okay.
Thank you, everyone.
Everyone.
Thanks a lot. Thank you so much.
Okay. Happy evening and take care.
Thank you, ma'am.
Happy
Thank you for
weekend.
the valuable FDP program.
Yeah.
Yes, ma'am,
Congratulations
please.
for successfully completing the program.
Yeah, yeah. We must say like that. Successfully we completed. It's a great thing.
Yes. Okay. Excuse me for winding up 15 minutes before. So,
Yes, sir. No problem.
take care. Bye bye.
Take care.